Hello and welcome to this webinar about how you can become cloud native without fighting with Kubernetes abstractions. My name is Daniel Higuero, I'm the CTO at NAPPTIVE, and today I will be your host for this particular webinar. So let's go. So the agenda for today will be, first of all, to talk about what is cloud native. Then we will move into where we can deploy native applications. We are going to comment also about why applications have become a key entity in the cloud native world. And finally, we are going to show you what we are doing at Native that can help you go into the cloud native direction. So what is cloud native? Cloud native is more than a technology or a tool if we take a look to the definition. It is more related to which are the practices and changes that we need to implement in order to be able to provide and develop cloud native applications. So in this sense, it's more like a methodological or philosophical approach to building software. So one of the key elements in here is that we are going to focus a lot on the service that we are providing. And by service, I mean the application that we as a company are managing and running and developing that is consumed by our customers. And this is the way that we have value into the chain, right? We want to have fast and frequent releases, meaning we move from once a year, once a month, once a week releases to do it as soon as you can. If you can do it many times a day, that will be the best possible outcome. That means that you are working in a rapid development lifecycle. So features need to be able to be split and defined in such a way that allow us basically to release little pieces of functionality as we have them available. And finally, we want to leverage the cloud functionality that is provided by the many different vendors. So let's talk first about some of the topics that appear when you start talking about cloud native and why they are important. So we take a look from the top left. We start with microservices. Microservices is an architectural pattern by which we split the responsibility of an application into smaller chunks. Each of those chunks will become a microservice. And the advantage of that is that we can have different development teams working in parallel in the application because they are working in different microservices. Microservices are usually containerized as the method of packaging them and distribution. A container in this sense is typically a Docker image that we build from a microservice, and this is how we run and deploy our application into a cluster, right? For deploying that, we leverage an orchestration layer that takes care basically of running our container in a cluster and takes care of what happens if a node fails, what happens if our container is rebooted or has an issue, things like that. In order to successfully do all of this, we need an automation layer that enables us basically to test and containerize our microservices and have a fast delivery chain so that we can move from just code to an image to a deployment as soon as we can. And another key element in here is dynamic management. Dynamic management is related to how we can adapt our capacity planning to the actual incoming demand from the users. So instead of making some static planning analysis, we can have some metrics that will inform the system itself, and the system will replicate the services depending on the needs of the particular demand that is coming right now to the service. That means that we can reduce the cost when that demand is low. And we don't lose clients when they come at the same time to our service, right? So which is the journey, how we can lead to this particular point in time, right? So if we take a look from the left to the traditional approach that we used to build software 20 years ago, typically we have an application that was compiled to a particular hardware architecture operating system, and we just deploy it in a particular computer, right? The issue with that was that typically those were linked together quite closely, meaning we end up with computers running just one application in many instances. And that basically motivated the movement through the virtualization world, where we started packaging our application as virtual machines and deploying those virtual machines. The advantage of that was that we were able to run different virtual machines at the same time on a shared hardware, and thus the utilization increased. After that, we entered the cloud world, and the initial offerings were around how we can deploy virtual machines into a third-party cloud provider, and that also evolved into running containers. So the classic cloud approach was like we have application in virtual machines or application into containers. We deploy them into the cloud provider. We take some of the services that were provided, and that was the plan, right? Now we enter the cloud native world. And at first it may be similar because there has a lot of similarities with the cloud, but there are some subtle differences, right? First of all, we need to consider that we are now running in multi-cloud deployment, meaning different vendors, different type of clouds, different type of deployments. And what we are usually doing is we have applications. Typically, those are always packaged as containers. We run them into a service that is managed by the provider itself. You can think of managed Kubernetes solution. And we also leverage other services that are provided to us, such as authentication, managed databases, managed messaging systems that are taken advantage to make our application faster, basically. So ultimately, cloud native is about how we can create and deliver software, not where we are running that software. So this is a key difference in the sense that we shouldn't care about which is the particular cloud provider that we are using. That doesn't give any value to our customer. And the value that we are giving is because we have an application that is running, and it's running as best as it can. And that's how we generate the value into our company, right? So what is the process? If we take a look from the left, we either have microservices and we package them as containers that we have described before and create a cloud deployment, or go through a migration process to take traditional applications, VMs, we either migrate them or try to deploy them as they are in case that we don't want to change them, we cannot change them, something like that, right? So which is the difference then, how we can become cloud native, because now we have a cloud deployment, right? So the other aspects that are important are how we can develop those applications better, right? So for that to happen, we need to change the company culture and product design. Those are highly affected because now we don't plan huge releases with huge set functionalities. We need to be able to develop small functionalities and provide them fast to our customers so we can have feedback also faster. In order to do that, the development process and the architecture need to adapt because we want to do this fast. So the architecture itself needs to support this addition removal of features without impacting the whole application. QI and delivery are two key elements. We need some robust pipelines that are running our tests, are creating our packages, are creating our containers, and depending on the case, even pushing them into the cluster themselves. Observability and dynamic provisioning are closely related together because we are also interested in understanding how each of the services work, getting metrics from them, and not only CPU RAM metrics. If we can have metrics at the application level, number of requests, number of new users that are signing up for the system, number of users that didn't buy X, that will help us also with the dynamic provisioning because we have real metrics of what is going on into our system, right? We also need an alerting layer that enable us to basically see and detect that something is going wrong and how we can mitigate it. And cloud agnosticity is also something that is quite important because at the end of the day, we are interested in running our applications and leveraging the providers. But if we decide to change from one provider to another, we want to have the freedom to do that and not to recode our whole deployment from one provider to another, right? So to illustrate different discussion through this webinar, let's consider this small application, right? which is just a web UI component that serves static HTML content that is rendered in the user browsers. You can think also having a mobile application if you wish. There is a public API component that will receive the requests from the users, pass them to a business logic component. It will perform some operations in there and some database to persist the data. So before we jump into the next section, let's see where we are right now, right? So we have talked about cloud native. We have basically described what is this. This is more about how we change the way that we develop software. And the key element in here is that the key aspect is how we are going to create and deliver software, not where we are developing software. Which is the particular cloud provider that we are using should be defined based on our needs and our cost analysis, but it shouldn't be important for the final user because it's something that is under the hood of our application. So let's move into the next section. So where should I deploy applications? Well, usually this leads us to entering the Kubernetes world, right? Kubernetes is an orchestration layer that takes care basically of abstracting the infrastructure that we have, the cluster that we have and the particular nodes. And it just sums up all of these as these are the resources that are available in a particular cluster. It will take care of running a container. And in case of different failures like a node fails, a node shuts down, maintenance, things like that, it will take care of moving that container around depending on what is going on in the cluster without bothering, let's say, the developer of the operator that is managing that application, right? So it takes care of container lifecycle and it takes care of abstracting the infrastructure. So if we talk just a little bit about the entities, there are two main entities in the Kubernetes world, which are pod and volumes. A pod is a collection of containers that are deployed together, and that typically is associated with one of our microservices. You can have replicas, you can have different type of deployment with different rules and things like that, but at the end of the day, you are deploying pods. Volumes are the way by which we can have persistent storage associated to that stateful pods or microservices. And this is just a small view of the two main entities. There are a lot more entities related to networking, security, and a bunch of other aspects that we are not going to describe around, but just consider that there are quite a few, okay? So what will be our application if we go into the Kubernetes world, right? So our application in this sense will be mapped as this application, as these entities. From the left, we will have an ingress, which is the abstraction that we use in Kubernetes to say this must be exposed to the outside world. Then we have the different elements, web UI, public API, business logic, and database. You will see that before each of them, there is a service abstraction. Before the deployment abstraction, the deployment will create the pods. The service will give, let's say, a DNS name for that particular service so that connectivity among them is easier. We have also added a config map and a secret to imagine that you want to have some configuration options for your business logic or some credentials to access the database. And in this case, just for the sake of simplicity, the database is deployed as a deployment. We are not going to enter into the details of the different type of deployments that you can have in the system, right? So which are the problems and challenges? Well, the main problem with Kubernetes is the steep learning curve that we have, right? There are a lot of entities in the system. That means that it's quite difficult to, at first, understand them sometimes. Contents may be quite confusing sometimes. And there is also the fact that there are some collateral effects. When you apply a particular entity sometimes that has an impact in potentially all of the other applications that are running into the system. So it's quite tricky to get an overview of what is going on, right? To complicate a little bit more each vendor at the end of the day has a specific flavor of Kubernetes. So some operations that are intended to be abstracted, like setting up an ingress, for instance, at the end of the day change depending on which is the vendor that you are using. So that means that not only you need to learn Kubernetes, you also need to learn the flavor of Kubernetes that is given to you by the provider that you are selected. So also we need to consider that there is no clear view of what an application is. There are just a bunch of entities, but you want to take an overview of your application, like the one that we had before, like what is this? You need to go through each of these individual entities, come up with, okay, whether they are working or not, which is the status, what they are doing, and consolidate that into your head, because there is no such application entity in the system at all, right? So let's focus now on the application, how we can solve this particular issue. So before we go into that, just let me remind you that the key here is that the applications is perceived sometimes in different forms depending on who are you talking with, right? So users typically see their application as it is running on my browser or my mobile application. But the reality is that this is just the last mile, let's say, of the application. The application itself lives in a cluster, it's a composition of different microservices, and they need to work together and work completely for the application to actually work. So if one of those services fail, we may have an issue with the customer because they may experience like the whole application is failing, but in reality, it is not. It must just be a particular piece of the application. So from the company point of view, we need to start focusing on the application as a whole and not individual technologies, vendors, or particular services. So to try to solve all of this, let me guide you through what the open application model is. This is a new standard that has appeared where the application becomes the main entity of the system. Instead of having pods, for instance, like we have in the past, now we have an application, which is the top level entity. It's a specification to describe how our applications are composed, how they can be deployed in a way that is provider and cloud agnostic, meaning if I need an ingress, I should be able to say, hey, I want an ingress for this particular application. That should work independently whether I'm running on AWS or GKE or any other place, right? So from the point of view of the application, the difference here is that we are starting to focus on what the application needs, know how do I get it, right? So if I need an ingress, give me an ingress. The abstraction layer should take care of, okay, for getting you an ingress in this particular cloud provider, I need to perform this amount of steps, right? If we have that abstracted in a particular runtime, that means that this is no longer the case that we need to start adapting our whole application deployments when we change from one cloud provider to another. We just change in one place, which is the runtime, and is maintained for all the providers, right? This standard is also sponsored by some major cloud providers like Microsoft or Alibaba. So it's not just a small community of developers. There is also a need for cloud providers to offer this type of abstraction layers, because at the end of the day, facilitate the way that we run applications, we maintain applications, and it also opens the door to change provider more quickly. So the main concept in OEM are, from the left, we have the application, which is like the top level entity that describes what do we want to run. The components of the applications, which are basically the microservices that you will want to deploy. And there are two extensions that you can apply to components, which are traits and scopes. Traits are a way to augment the functionality of a component. For example, if I have an Nginx component and I want to expose to web, I just will apply a trait saying create an ingress, expose this particular endpoint, and that should happen. The same if I need to say, hey, I want the logs from this application to be redirected to this particular system. I can apply a trait to the component, and that means that the component itself, the core logic, doesn't change. We can just augment the functionality depending on the type of deployment, the situation that we are in, right? Scopes are similar in some aspect to trait, but they are applied to a group of components. You can imagine things like, I want these two particular components of my system to be able to speak among themselves, but not with others for security reasons. I want to have health status depending on different subsets of components, things like that. So if we move now our applications, the one that we have described at the very beginning, into OEM, what you will see here is not now from the left, you will have an application entity, that's my app version 1.0, the different components, the web UI, public APIs, and logic and database. And then you will have some traits. You can have traits for config maps, secrets, for the ingress, and we also have added, just for the sake of discussion, a health scope for the backend, so we can have different points of view on which point of our application is actually running, right? So the key here at the end of the day is that this is not just about containers, right? For a container to be successful, we need to have a whole environment that encapsulates all the tools and provide the tools that we need to run that container. So this is not just about creating a particular container and putting them into Kubernetes and say, that's it. No, it is not. There is a lot of tools and a lot of needs that we want, such as logging, alerting, monitoring, things like that, that need to happen for us to be successful. So to complement all of this functionality with the vanilla Kubernetes deployment, let's say, we can do two things. Either we go to the CNCF landscape, and you will see that this is actually quite vast and unapproachable. Just in the past year, there were 35 new projects added to the foundation, meaning potentially 35 new projects that you may want to use in your applications and may give you an advantage. But the time it takes to actually understand and deploy them, create proof of concepts, and that things may be unapproachable for many companies. Other companies tend to go with the internal tool path, meaning, okay, I will create an in-house solution for this particular problem. The issue with that is that this is usually quite costly and usually needs a level of expertise that is also quite high. So they are not just that easy to build in-house. Some of the common needs that we want to extend our Kubernetes platform with are auto-reasoning modes, supporting multi-tenancy, things like namespace as a service for development, for instance, so that each developer can have a piece of cluster that they can run their tests and their development on, support for agile operations, monitoring and logging of the application for the observability layer, and dashboards to understand what is going on, what is my application doing, which is the state of the deployment, things like that. So now let's go into what we do at NAPPTIVE to try to help you go into the cloud native world. So at NAPPTIVE, we have three main products that we are working on right now. On the bottom, you will see KubeNapp, which is a collection of tools that we are working on to extend the functionality of vanilla Kubernetes, as we have described, for instance, to give you an ingress for a particular component. The Playground is our software as a service offering, where you can just go and you will have on-demand namespace as a service solution for you. And obviously you can deploy OEM applications on that. The runtime is already included. And we are also working in the catalog, which is similar to what you have in Docker Hub for containers, but this is for whole applications, meaning you will be able to publish your application in there and deploy the in just one go with all the components that are needed. There will be also a collection of common tools, such as databases, that you can just instantiate into your namespace and use it for your applications. Things like databases, for example, right? So to show you this, let's start with a pretty simple application, in this case WordPress, which is composed of just two components, WordPress and MySQL. There will be an ingress and health scope to illustrate how you can use this in OEM. So let me show you first the application. So in OEM, you will have this application configuration entity, which is the top level entity in this version. And there will be two components, right? MySQL and WordPress. You can have parameters to configure how you want to deploy your particular component in this particular instance, because you can reuse them. And you can apply traits, as we have described before, to say, hey, I want to expose WordPress to the outside world, take this path, this port, and create an ingress for that. And some health scopes that you can check to see the health status and things like that. If we take a look to the component, you will see that this is similar in some sense to what you can do with Kubernetes, but there are some simplifications in the way that you specify things like parameters, variables, and things like that. So let's jump now into the terminal. Let's first of all log into the playground. Okay, so next steps will be obtain the kubeconfig file that will allow you to basically work with your cluster. You can get information about the cluster that we are providing you with this command. And now let's just deploy the application, right? In this case, WordPress MySQL. You will see here that the application has been deployed. There are the components, the health scope, and all of the elements of the application has been deployed. You can check the status of the application with this command. And now we are going to jump to the web user interface, so you can also see what is going on, right? So you will see here that you have my WordPress application. There are two components, MySQL database with the parameters that we have just set, the health scopes, and this is WordPress, right? So what can we do with the application? Well, first of all, if you are interested in things like obtaining the logs of the application, you can do this by just issuing this logs command, and you will see here like what is going on, which are the logs of the different components. You can refine them by component, by application, things like that. Well, on the web UI, you will also see like which is the amount of CPU and RAM that you are consuming for this particular namespace that we are providing you with. And if you go to this WordPress component, we have set an ingress for this, so that endpoint should lead us to basically WordPress. Okay, so this is how you can interact with the playground and how you can deploy applications with it. So let's continue now with the presentation. And we want to finish with how we see the future of cloud native, right? So we'll see a movement to more integrated platform. As we have seen before, there are a lot of vanilla frameworks that you need to put together to accomplish something realistic for production. So I think there will be an increase in the integrated platforms. Taken into consideration that infrastructure at the end of the day is becoming a commodity. It's not that important where you're running your application. You are focusing on running your application itself. The business generates value through the application. This is something that is starting to happen, and you can see this in more layers of the business. People are realizing like, hey, this has a specific core business value and we need to maintain it. There will be obviously an increase in the way that we deploy applications and develop applications. We want features fast, soon, and put them into the customers as soon as we can to be competitive. And multi-cloud deployments are also one of the key challenges that many companies are going through right now, which is like, how can we live in two cloud providers, for example, either because we want to consider some failure scenarios to be more reliable, or because maybe we are figuring out a way to migrating from one to another because there may be a cost benefit. There will be a better offer in a third-party cloud provider than the one that we are using just right now, right? So with all of that said, just please go to the playground and join the playground, and you can try by yourself. It is free to use. You will be given a namespace that is available for 24 hours. After that, you can renew it as many times as you want to. Every time that you connect, you will get basically a new namespace once the 24 hours are set. So please use it, comment, and check it out. So with all that said, thanks a lot for attending this webinar. I hope you find it interesting, and please reach out the way that you want. If you have any questions, we are happy to help you with anything, to discuss your use case, to see how native can help you go into the cloud native world. So please reach out, and thanks a lot.